In this video, we will be taking a look at the measures of central tendency. Measures of central tendency locate the center of the distribution based on where most of the subjects or people fall. That is, where most of the subjects lump together. There are three measures of central tendency: the mean, median, and mode. Each has its own strength and weakness. You can find more information in our book on median, mean, and mode on page 147 to 157. If you do not have the book, just continue with the video to find out all you need to know about the measures of central tendency. Let's take a look at the basic concept behind the measures of central tendency. Interval or ratio measure on a randomly selected group of subjects will form a distribution approximately like one you see here. Notice how most of the people fall towards the center, with fewer people at either end of the curve, called the tails. For example, if this was a distribution of height for males, most would be between 66 and 71 inches in height. We will explain where these numbers came from in the video on measures of variability that can be found on our YouTube site. On the right-hand side of the curve, on height, would be the basketball players. And on the left-hand side of the curve might be those people, for genetic or environmental reasons, are very short. But the bulk of people will remain around the center of the measure. The mean, median, and mode are how we locate the center. So let's start with the mode. On this curve, the mode is the value of x, where the most frequent, whether x represents on test, height, weight, and so on. The mode will always be the highest point on the curve. Sometimes you get a bimodal distribution, one in which there are two high points. On randomly generated data, however, bimodal is rare. The mode has some limitations. First, it is the most often reported on nominal data. For example, if you surveyed people on their favorite sandwich, and most people picked peanut butter and jelly, that would be the modal most frequent response. Additionally, the mode is not very sensitive to new data. For a height example just a bit ago, suppose the modal height was 69 inches, the highest point on the curve. Now suppose you add another subject who stands 7 feet 8 inches. That would be 92 inches. Even though you've added this person to the distribution, the high point is still going to be 69 inches. So this subject had no effect on the mode. This really makes the mode a rather weak indicator of central tendency. Now let's look at median. The median is that value on x that divides the distribution in half, with 50% of the subjects above that value and 50% below. Quite literally, you were looking for the value of x for a specific person in the distribution, the person in the middle, such that the person's value on x divides the distribution in half. The median is often used to divide a group of subjects into two groups, one group above the median, one group below. This is called the medial split. If you have a simple frequency distribution with an odd number of subjects, the median will be the middle value of the numbers in the distribution. If the number of subjects is even, it will be the average of the two center values or numbers in the simple frequency distribution. Here you see the formula for computing median. LRL stands for the lower real limit. Remember, all intervals or ratio numbers have a lower limit, half below and half on the upper. So 35, for example, extends from its lower limit of 34.5 to its upper limit of 35.5. Target CF in the formula is always found by multiplying the number of subjects, or capital N, times 50%, or 0.50. So if you have 189 subjects, target CF will be 189 times 0.5, or 94.5. CF below are the number of subjects below the target CF. That is, how many subjects had values or scores from 0 to 94.5. F within is how many subjects had a value or score between 94.5 and 95.5, Or, if the data are whole numbers, how many subjects had a score of 95? The interval size is the width of the interval. In a simple frequency distribution, it will be 1. So for example, 95 has a width that runs from 94.5 to 95.5. If we subtract 94.5 from 95.5, we get an interval width of 1. Here you see the formula for computing the median, or a score at any percentile. Just insert the percentile you're looking for in place of 50% or 0.50. The formula will work with any distribution, but we will not use it for a simple frequency distribution. It is easier to do the middle value or score from an odd number of subjects or average of the middle two numbers or scores if it's an even number of subjects. Let's see how it works with a distribution that is a bit more than a simple distribution. Here's a grouped frequency distribution. What is the median score? First, we find target CF. We note there are 30 subjects, or 30 times 0.5 equals 15. We put the number in the formula. We will be looking for the score of the 15th person. So going down the CF column, we find that the 15th person falls in the 56 to 66 interval. The LRL, or lower real limit, of the interval is 55.5. We put this number in the formula. With a score of 12 to 55.5, there are 10 subjects. That is the CF below. 6 people actually have scored in the 56 to 66 interval, that is F within. And finally, the interval width is 11. Count the numbers in the interval. Do not subtract the lower number of the interval from the upper number. 66 minus 56 is 10. But there are 11 actual scores in the interval. Now, working through the formula, we find a theoretical median score of 64.666. The median score just calculated is an approximation and assumes that subjects within an interval are equally distributed across the interval. For example, one assumes the 6 subjects fallen in the 56 to 66 interval are equally distributed across the interval. There are limitations to median. For example, if one were to add a really tall person to the distribution, as we suggested earlier, the median will move by only a half of a person. Think of it this way. If the distribution is composed of 189 subjects with a target CF of 94.5, and then you add that tall guy, the number of subjects changes to 180, and the target CF now becomes 95. Now we look at the mean. The mean is the arithmetic average. It is the best indicator of the center of the distribution, and therefore the strongest of the 3 measures of central tendency. Parametric statistics are based on the mean. The formula is quite simple. It is the sum of the values of x divided by the number of subjects. Note the mean is represented by x with a bar over it. Also note that the Greek letter sigma means to sum. Thus sigma x means to add together all the values of x. N is a capital. N, so it means that the total number of subjects. Going back to our height example, you would add the height of all 189 subjects, then divide by 189. This will give you an arithmetic average called the mean in statistics. Here we will see the mean computed on a simple frequency distribution. We have 8 subjects, 8 values for x, each occurring one time, which means that the total number of subjects will be 8. We add together the values of x from 12 to 89. The sum will be 403. That is the sum of x. Now we divide 403 by 8, the total number of subjects, and our mean becomes 50.375. Of importance, you must add the same number of scores as you have subjects. So if you had a frequency distribution with 5 subjects, had a height of 72 inches, you must be sure to add 72 into the sum for the height 5 times, or multiply 72 by 5 and indicate that number in the sum. Some final thoughts on mean, median, and mode. If a distribution is symmetric, as in the top one, the mode, median, and mean will all be the same value. Conversely, it is the mode, median, and mean are not the same number. The distribution has to be skewed. On a skewed distribution, like the second example, the mode will still be the highest point, followed by the median, then the mean, in that order on the long tail of the curve. On really skewed distribution, the median is often a better indicator of the center than it is the mean, but more on that later. Thanks for watching, and please check out our YouTube channel for more videos on statistics and research methodology.